Hello and welcome to this mini-series about Java Reflection API, where we try to rebuild and recreate commonly used frameworks, libraries, functionalities that are reflection-based, like JSON mapping, annotation-based validation, and dependency injection. In the first part, we covered class inspection, how we could scan unknown objects and classes for their fields and extract their values to generate simple JSON string. On the second part, we covered annotation processing, where we saw how we can put our custom annotations on some fields to enable customization from the end user's perspective. They could add annotations like JSON ignore to ignore the field or JSON property to rename a field. In part 3, it was quite technical, so we wanted to give a user a possibility to make a transformation before outputting something into JSON. While it was quite simple, we just wanted to handle method and invoke them at runtime. The problem lied that we have to structure our code and find common inheritance, common classes to combine lists of fields methods together, that we have one single pipeline for processing it. And as for today, for the last part, we would want to have some end state where we can actually use our JSON mapper on some nested structures that contains arrays, collections, and get our desired output. Let's start with the nested objects, as arrays and collections will be quite similar in handling. So once again, we follow TDD approach, where we want to define our requirement as a test before we implement anything, so we are strictly know what we want to implement. And also by this covering our previous features that we know that we have not broken. Remember last time we actually had some situations where thanks to tests we have detected some issues. So for our test we need some nested structures, so our class needs to hold some other class inside. So for example, let's create a blog post that has a title and author will have a name inside it. Then we generate an input where we will fill in our values and run the test in the when section. After capturing the output, we need to compare it to our expected value. So in our case, it will be a JSON structure that has a title Java, and there will be another field author that is a JSON object itself that has a own field name, value John. But remember, when we will run our real implementation, there is a chance that this order could be changed because we have this ordering affected by the duplication that we have in our code. For now, I think this test is okay. So running this test, we should expect it to fail. Indeed, we see the test has been failed. Currently, the output, as I mentioned, could be in different order, but anyway, author is just a toString of a record. It's not a JSON structure, it's just a toString value. Title works as expected. So if we quickly go over what we have currently, we have extracted fields, we have extracted the methods that are annotated with JSON property, we have combined them in single stream. Then we remove all of the fields and methods that are marked by JSON ignore. When we have filtered out those methods and fields, we want to collect and have the unique members, collect them to map, where key is the name of either the field or the JSON property attribute that we use to rename it. And the value is a JSON representation of this value. Then we have the third parameter, which is a merge function, where in case we have a duplicate that we had last time, there are like two authors, for example, present, we will just pick one. When we have collected all the unique members, we just collect them following the JSON key value pattern and collect them using joining. So we have a delimiter comma between them, starting with JSON object opening and JSON object closing. You can see that we have structured our code very well. We have separated concerns to a different methods, so they are doing their own parts. So for example, extraction of name is doing in the getName function, and mapping a value into a JSON value is happening as a JSON value method. So it looks like the nested structure actually needs to be handled here. If the value is primitive, then we return a string representation of it. So if it's a number, we just return a number without adding these quotes. Otherwise, we know that we need to have a quotes around them. So if it's a string or something else, we put quotes around the string value. So here is the perfect place where we need to handle our nested structure. So let's define a function that would check if the object is nested, and we should cover it by nested scenario. Remember, when working with TDD, we work with iterations. Our goal is not to implement the perfect scenario immediately. We want to have an incremental improvements over time. So we want to start slowly and get the test green with minimal changes and then enhance and improve it. So let's start with quite dumb checks. So we know we have our K function is primitive. Let's say the object is nested if it's not primitive. Of course, you would ask why we need such function. We could just put here an else case, right? Like else, and we consider it nested. But we know that there looks like a third case because something needs to be quoted and not handled as nested. But let's start slowly and come to it. Else if the object considered to be nested. If the field is a nested structure, technically we just need to repeat all the steps that we did. We need to scan for fields, we need to scan for methods, and generate the string. Basically, it means a recursion. We need to call ourselves again. So if we see that it's a nested structure, we will just call our toJSON function on this value. Okay, let's run the test and see what we got. And we failed with some sort of exception. So it looks like we're trying to dig into the string and consider it as a nested structure. Well, technically string is not a primitive, it is a nested structure. But this is the case that we would like to skip and provide just a string value. So here, if the object is not primitive and not instance of string, then we want to skip it. And we see that test has failed, but the logic worked, it's just the ordering. So let's change the expected value to have this order. So there is author, inside a nested structure name, John, and title. Fixing the order also fixed the tests. So we have successfully implemented this functionality. But before we go on, let's double check that we have not broken anything. And actually running the tests, we can see that we have one failure. Should correct map primitive fields. When we check out this test, we can see that we actually got a Stack Overflow error. But what's there such that it could fail on primitive level, given that we have already the handling for primitives? And the answer is the char. So we have covered bytes, shorts, ints, longs, all the numeric values and a boolean, but we have not covered the character. Because we want to have our character in quotes and not as a single value or a numeric value. By excluding the character from the primitive case, it jumps into a nested case and fulfills there. So we need to expand our isNested with additional class that is character. And let's rerun the tests and we can see we have fixed that issue. So for now, let's finish with this feature and go to the arrays. So once again, let's start with a test and define a structure with an array of primitives and test if it will be mapped correctly. So given we have a student with grades, then we map it to a value and we want to compare with the expected case. So we expect that there will be a JSON grades holding an array of primitive values in order. Let's run the test and confirm that it's failing. And indeed we see that grades are empty string. So it's not handled in any way. Following our pattern, let's define a function that will determine if it's an array or not. So array is something specific. It's not like we are implementing some sort of class, but there is a helper method in reflection that can tell if a class is an array or not. So we can check if value get class and there is a function isArray that is returning boolean. And let's handle array before we handle the nested structure. So else if isArray value, then here we need to perform our specific actions for handling array. Let's go somewhere down and add it. So private string to JSON array. So our goal is to iterate over all array and concatenate all the results together. We could define a for loop, but we need to know the length of the array. So there is a method in array class called getLength. So if we want to implement it in a more traditional way with loops, we could have something like for e is less than array getLength. But if we want to follow a more modern Java approach, we can actually replace it with a stream. So same thing can be achieved with an in-stream generator, where you can define a range starting from 0 till the array getLength of this array. So what we have just created is a stream of indexes. So 0, 1, 2, 3, 4, 5, etc. And by this, we can replace our for loop. And we want to extract the value that is at this current index. And again, we can use array reflection class, get, provide an array, and an index. And let's separate the mapping of this value from the extraction so it's more readable. So we want to map as JSON value representation. And one of the main reasons why I wanted to switch to streams instead of loops, because it's much easier to collect this into a single value. For example, remember the collectors joining, where we can provide a delimiter, we can provide a prefix and a suffix. Now that we have everything, we can just return a result. So again, we are generating all the indexes, going one by one, extracting a value from an array, then we are converting it into a JSON value and collecting inside our array brackets. And now we need to go back and add this to our branching here. So return to JSON array and provide this value. Okay, let's rerun the test and see. So you can see it's indeed just grades with an array of primitive values. And before we go on, let's quickly check if it works with strings and nested structures. So running it for strings, we have a group with names that are string type. We expect John and Jane as values. In the result we see, yes, there is a names keyword and it should be quoted values inside. Let's run the test and it's green, working as expected. And as for the next structure, we have a group that have a list of students and each student has a name field. So we in input have a group of 2 students, John and Jane, and we expect them to see in the same order. So you can see in the output, indeed there is a students field, curly bracket, starting object name John, ending object, starting object name Jane, ending object, ending array, and the parent object. And now just for sanity, let's rerun all the tests. And everything is green, so we have successfully implemented our simple feature. And the next step would be to include our collections inside JSON output. And you know that there are many implementations for the collections for our different types of usages. So there are lists, maps, sets, etc. Well, many of them are index-based and similar to arrays, and we could implement them like that. Still, we need to understand that there is some differences and some exceptions. So if we look at the hierarchy of collections API, like array lists, queues, hash sets, they implement their own interfaces like sets, queues, lists. So interface itself extends the collection interface, which on its own extends iterable. So iterable means that we can iterate over one element by one. So technically it means we can handle them similarly as array, except for map. If you look closely, map is an exception that is not implementing a collection and is not implementing an iterable. Well, some implementations could be, but in generic, a map structure is not doing that. So for us, it really means that there are 2 types of collections. One is iterable based, another is the map. So we need to handle these both cases. So let's quickly define a simple case for a list. So we have a student that now instead of array has grades as a list. We provide list inside with some implementation. And in the result, we want to have the same output as in case of an array, just the square brackets and the values in order. Okay, here we follow the same pattern, right? We can extract it as a isCollection method where we provide this object value. And we want to understand if this is instance of collection. Now then we here included, for example, after our isArray check, isCollection. In collection, there is a method called toArray that will transform our collection into array of elements. We can actually reuse our existing implementation of array. Here we can just cast to get our collection and return to JSON array asking this collection to be transformed to an array. So running our test is green and we got the expected result. So we could continue and check for each data structure or for each interface, but we know that if it's a collection, there should be a toArray method, and we know that array for us works. So let's leave on this. The only thing that will not work is the map. Let's define a test for our map. We have a student that has a map of string integer key value pairs, grades, which is like a map of the subject and the grade that you have in it. So math 7, English 6. Then in expected output, we should see again the grades and not the array, but a nested object with the key math coming from it, value, English, another key, and again the value. So let's run the test to see that it fails. So again, here we fail with the exception of accessibility. We were trying to extract this map as a nested object, and we know that there are internally fields, and we don't want to do that. Last thing that we will add is map check for object value, and we will verify if the value is this instance of map. And let's do the check before the nested structure. So let's create a helper function. Do JSON map and pass here object value. So we know it's a map, so here we can here just cast it. And so here come some problems that we need to consider when working with maps. Is that the key can be anything. It can be an array, it can be an object, it can be a string, it can be a number, it can be another class. So there should be some proper output for each of them. And for us not to overthink right now, let's keep just the toString output. So if it outputs something in toString, we use it as a key. We can take the entry set and go over it in a stream. Again, we want to do the same steps that we did, that we have an entry. We want to map it to a JSON pattern, like key value pair, where the first value is the entry get key. And the second one is this our as JSON value entry get value. Now that we have it, we can collect this result, again using our collectors, joining, similarly like having the delimiter, bracket and another one, and return things back. Now going back on our implementation, so if it's a map, we return to JSON map and provide the value. And result in a failing test again, and if we compare what is the reason, it's the ordering again. Our map does not persist order, so if we want to have math English, sometimes it can be English math, and actually it can be dependent on the runtime. So if we rerun it again, now it's green. So there could be two versions of our output, and we would really want to expand it to handle both. And then change the assert equals to assert true, for example, and have actual equals expected 1 or actual equals expected 2. And now our test is no longer flaky and can be used. And by this we have implemented most of the things that we need for our basic JSON mapper. But of course you can see that code is not optimal enough. We have this not beautiful if statement tree that is basically handling different scenarios. And not only that, if we imagine the nested scenario, there probably are more values that we would like to exclude from being handled as a nested object. For example, datetime, instead of having array of integer values, we would like to have some sort of specific date format. So usually in framework this is done with custom components that you can register, and that would be much better approach how we could structure our code. For example, there would be datetime formatter that would return a string representation of date. And user could override or introduce its own mappers. We will cover something similar next time when we will perform annotation-based validation, because we would like to have custom user validation annotations. But for now, I think we have done a great job. Except we always have ignored one little nasty thing, and that's null value. If you provide a null field or anything else, it will fail, and we have not yet covered that case. And it's just simple as adding two additional if statements. The first if statement is added to our if-else tree, where we check if the value is null, then we return just a null text representation. And second one is our on top level public function that we use. If the object itself is null, we also return just null. To verify that quickly, we have two tests. One will handle null object itself, so if null is provided, we just return null. And the second one, if we have a null field, like a student name, we want to output it also as null. Let's rerun all the tests, and everything is green. Success! In these 4 parts, we have successfully finished with our JSON mapper. Congratulations! So, we saw how using Reflection API we can scan classes for fields, methods, annotations, how we can get values from private fields, how we can invoke methods to execute some custom code, to see what return types and parameters there are. So Reflection is a really powerful tool. And in this case, as mentioned, our code was quite static, so it was not being really extendable. Next time we will move to our new project, which will be annotation-based validation, where we can put annotations on our class, for example, not null, and validate them automatically. And there we will provide a way how user can extend with custom implementations. So if you like what you see, please subscribe, leave a like, leave a comment. Your feedback is appreciated here. But as for now, I hope to see you next time.